All right, let's talk about population proportions. Let's start with an example. Let's suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. So 500 randomly selected adult residents in the city are surveyed to determine if they have cell phones or not. Of the 500 people surveyed, 421 responded yes, they own cell phones. Using a 95% confidence level, let's compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones. Before we jump in and actually answer this, let's think about how this is different from what we have already done. Well, we don't have like a mean or a standard deviation, right? They either have the cell phones or they don't. That is binomial. Remember binomial? And we know that there is a proportion of people that meet the criteria. So that indicates that it's something different than what we have been doing with means and standard deviations and whatnots. So, how do we know it's a proportion problem? Well, first of all, the underlying distribution needs to be binomial. And the random variable x is going to be equal to the sum of the sample size n from the binomial, which is normally distributed by the central limit theorem. In fact, it's distributed normal n times p root square root npq. So to perform the proportion random variable, we're going to take x and divide it by n. And this new random variable is called p hat. Written p tick. I like it with a hat better, but our book uses a tick mark. X over n, and it's distributed normal p square root pq over n. So let's go back to our example. So this population is binomial. Either yes, they have a cell phone or they don't. In this example, our n is 500 people, and our number of successes are 421. So the sample proportion p hat is going to be 421 over 500, which is 0.842. To figure this out, we're going to use another online calculator. Remember, n is 500, the number of successes is 421, and the confidence interval is 95%. I can remember those things. That'll be exciting. It was 95%. This is a different calculator. This is a different one than we've used. We've used the sample size one. We've used the mean one. This is the confidence interval for a proportion one. So we want 95% confidence level, one sample. Well, you can either put in p hat that I computed earlier, or you can put in successes, which I think was 461. I already forgot. 421. 421 out of 500. And hit calculate. And there is your confidence level and your p hat value, which we already computed to be 0.842 as well. So going back to that, I lost my spot. Hang on. All right, so there are results that we got. So we took 0.842 and subtracted 0.0319, got 0.81. Took 0.842 and added 0.319, got 0.874. So that's our 95% confidence interval. So we estimate with 95% confidence between 81% and 87.4% of all adult residents in the city have cell phones. So what does that mean exactly? What does a 95% confidence level mean? It means that 95% of the confidence intervals constructed in this way would contain the true value of the population proportion of all adults residents in the city. All right, the +4 confidence interval. So there is a certain amount of error introduced into the process of calculating a confidence interval for a proportion. One trick that we use to do that is you pretend that we have 4 additional observances. 2 of these observations are successes and 2 of these are failures. The new sample size then is n plus 4, so 4 more observations. And our new count of successes is going to be x plus 2. The reason why this works is really beyond the scope of this class, but computer studies have shown that it is very effective and makes the confidence level at least 90% when the sample size is at least 10. I mean, it should be used when the confidence level is desired at least 90% and the sample size is at least 10. So this is a good thing to use. So let's do this example. A random sample of 25 statistics students were asked, have you smoked a cigarette in the past week? 6 students reported smoking within the past week. We're going to use the +4 method to find a 95% confidence interval for the true proportion of statistics students who smoke. So in this example, our confidence level is 95%. Our successes are 29 because our successes are 8 because 6 plus 2 is 8. And our sample size is 29. And and we come up with this new confidence interval that is between 0.113 and 0.439. Now, only do this if you're asked to do the +4 method. Let's do another example. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 and up who use text messaging on their phones. How many customers aged 50 and up should be the company survey in order to be 90% confident that the estimate proportion is within 3 percentage points of the true population proportion? So this is another example of those sample size kind of questions. And we're going to use the same sample size calculator that we used before. It's a proportion. We don't have an estimate for p hat. Our confidence level is 90%, and our margin of error is at 3 percentage points. So we have that all noted. Let's go ahead and open that sample size calculator again, which we've used before. All right, so this one, you click proportion this time. Do we have an estimate for p hat? We do not. Our margin of error, I think, was 0.03, and our confidence level was, I don't remember. I should remember, but I don't. 90. I'm going to complain about that. 0.90. And let's calculate it. So the sample size is 751.5. Remember, you always round up on sample sizes. So let's go back to our problem. On the right screen, sorry. We did our calculator, and this is the result we got. Remember, we're going to always round up to 752. So this is a proportion. We don't have a preliminary estimate. We didn't have a preliminary estimate for p hat. 90% confidence level, margin of error 0.03. We need a sample size of 751.5, so that's 752 people. All right, so this brings back, what do I use when? This chapter 8 has had a lot of different calculators and a lot of different scenarios, so I'm just going to take a couple minutes right now to kind of go over how you know which to use when. So if we're talking about confidence interval for a mean, we have two choices. We can use a normal distribution, or we can use a student t-distribution. We use the normal distribution if you know sigma. If they tell you, oh, the population standard deviation is this, then you can use the normal distribution. If you don't know sigma, but they give you some data so that you can calculate S, then you use the student t-distribution. If you're given a big batch of data, probably it's going to be the student t-distribution. Then you go ahead on your own and using your methods that you know to calculate X bar and S, the sample standard deviation. All right, what about for confidence interval for proportion, which we just talked about? Look for the binomial aspect of the problem. Is it a yes, no kind of situation? Also, it almost certainly will have the word proportion in it somewhere. So look for that word to tell you that you should be using the confidence interval for a proportion. Okay. Most of the time, the confidence interval for a mean will say mean as well. Finally, sample size calculators. We use the same sample size calculator with different settings for all three of these, right? And so you can use them anyway. You just have to know that you're looking for the sample size for a given confidence level or confidence interval and a given margin of error. So you always are, you're going to be like, oh, how big should my sample be for this, this, and this? And then you should know that you should use the sample size calculator. Don't forget to always round up. Always round up, because otherwise you won't meet the basic minimum requirements. All right, that's section 8.3.